To combat problems such as piracy, people trafficking and aid distribution, the fleet must operate in shallow coastal waters, known as the littorals. And as shipbuilding program manager Captain Tom Anderson knows, this requires a particular kind of vessel.
To operate effectively in the littorals, we need a high-speed ship, and it's got to be adaptable. It's got to be capable of doing multiple missions. That's our challenge.
A challenge that Chief Engineer Lieutenant Damon Gilbert is also familiar with.
The ideal ship for this environment would be a ship that's light, a ship that has a very shallow draft, and a ship that can handle itself and move very quickly.
The solution: the Littoral Combat Ship class. Made up of the monohull Freedom variant and the Trimaran Independence variant, this new class of ship represents the vanguard of marine engineering.
This is the face of shipbuilding in 2017. This design, whether it's the monohull design or the Trimaran design, this is going to change the face of how we operate inside those waters for years to come.
Built for speed, both the Freedom variant's semi-planing hull and the Independence variant's Trimaran design create ultra-hydrodynamic efficiency. Using lightweight aluminium powered by an innovative propulsion system, each ship can travel in excess of 40 knots in little more than 4 meters of water. Designed to be reconfigured for multiple missions and deploy smaller boats, a vast helicopter pad extends the crew's reach. To produce a high-performance fleet for shallow waters, Littoral Combat Ships designers faced a series of complex engineering challenges. Perhaps none more difficult than finding the most effective propulsion system.
So to make a traditional propeller system work, the propeller blades need to sit below the hull so they get the proper flow, which would add to our draft.
Not only do standard propeller systems increase how far the ship extends below the waterline, they're relatively slow to react.
In the littoral waters, if you want to chase down a ship or you want to elude another vessel to get out of danger, you want to be able to maneuver as quickly as possible.
So how do you propel a ship at speed in swimming pool depths? This would not have been possible without a genius innovation from the past. LCS engineers on both the monohull and Trimaran variant have taken Hamilton's water jet innovation and used it to create a propulsion system of unparalleled performance.
Ship has a requirement to do 40 knots. 40 knots is a very high speed for a ship of this size. The way that this ship achieves that speed is through the use of 2 gas turbines and 2 diesel engines that drive a propulsion train that is propelled by water jets.
At Austal USA's shipyard in Mobile, Alabama, the latest Independence variant USS Tulsa is having her jets inspected, ready for launch.
When this ship is going full power, there's roughly 24,000 gallons per second passing through these 4 water jets, which equates to the ability to fill 2 Olympic-sized swimming pools in less than a minute.
Not only do they generate colossal power, these cleverly engineered jets act as a rudder to steer the ship.
Each water jet is capable of independently being steered, which allows for a lot of flexibility and maneuverability.
Like Hamilton's system, water is ducted through 4 mighty impellers and discharged at high velocity astern. To steer, each jet's water flow is deflected by a rotating nozzle, enabling fast, agile maneuvers. And to reverse, the exit nozzles force the jet flow backwards. Built into the hull, the LCS can operate in just over 4 meters of water. The littoral combat ships are the quickest and most agile in the US Navy. Program manager Captain Tom Anderson believes their performance is unsurpassed.
If you're a pirate or you're a drug runner and you see that ship coming towards you, it's time to shut down your engines and put up your hands.
Built for multiple missions, the Trimaran Independence variant and the monohull Freedom variant are engineered to patrol the planet's coastlines, known as the littorals. But to operate fully loaded at speed, without running aground in these shallow waters, the ships must be as light as possible.
Every pound that goes into the ship is assessed, because every pound that goes into the ship is an increase in its draft and a decrease in its speed.
For Lieutenant Damon Gilbert, USS Freedom's chief engineer, solving this problem is crucial.
The difficulty we find with the older ship designs is the steel hull with the steel superstructure makes the ship incredibly heavy. The less weight we have going into the littorals equals a smaller draft. Smaller draft equals a longer sustainability inside those littorals without worrying about running aground, without worrying about getting into situations that we can't come back out of.
Taking inspiration from aerospace, LCS Freedom variant engineers have used high-grade aluminium to create some of the lightest combat ships of this size ever built.
One of the design elements that was put into this particular design of LCS was a bimetallic hull, meaning the actual hull itself is steel, where the superstructure, or what we like to call sometimes the house where people live and where all the facilities are, is actually comprised of aluminum, thus saving literally tons of weight, which has a direct effect on the draft.
In spite of the Freedom variant's 118-meter length and 17.5-meter width, with its steel hull and aluminium superstructure, it weighs a mere 3,500 tons with a draft of just above 4 meters. Engineers on the Independence variant, however, have gone one step further.
So the L in LCS doesn't stand for little. We're building a sizable ship here. As you can see, as you take a look at the stern of the ship, this ship is the largest all-aluminum vessel operating on the seas today.
Constructing these Trimaran megaships in Austell, USA's Alabama shipyard, at 127 meters long and a colossal 31 meters wide, every kilo counts.
Aluminum has great strength-to-weight ratio. It's a third of the density of steel. And for the volume of ship we're building here, aluminum structure was the only way for us to meet our speed, range, and draft requirements. So as we take a look inside the ship, you get a feel for the structural members, and the construction, including the external sheathing, is all aluminum.
And taking Alfred Wilm's approach, adjusting the recipe, their marine-grade aluminium has one remarkable quality.
Aluminum alloys that we use in construction of this ship have good corrosive properties, which means, unlike other Navy ships where exposed steel needs to be painted, this ship is not painted above the waterline. That saves us money, and it also reduces the weight of the ship.
And that huge weight reduction means the Independence variant's draft has been dramatically reduced to just over 4 meters.
Normally, we would have about twice the draft that this ship has. And that enables us to go into waters and visit ports that traditionally our Navy ships have not been able to get into.
It's a pretty incredible feat of engineering in order to get a ship this size to have a draft of only 14 feet, but still be able to maintain maneuverability in deeper waters.
The US Navy's cutting-edge littoral combat ships are taking marine engineering to new heights. Built to patrol coastal waters for Program Manager Captain Tom Anderson, the LCS is a standout class.
Operating in the shallows require high-speed ships with shallow drafts. The answer to those challenges is the littoral combat ship.
Littoral combat ship engineers have taken the principles behind Chet-Chet's racing yacht and created the Navy's first high-performance trimaran combat ship. At Austell, USA's shipyard in Alabama, the USS Tulsa is receiving its finishing touches.
You can see I have very fine-tuned bow designed to pierce waves. As we go further back, you see the hull widen. And just here to the right, you can see the outrigger. And again, just like those canoes, with the outriggers, which give us that added stability, we get high speed.
The stabilized central hull with two outriggers moves the ship's displacement point upwards, reducing drag, allowing it to reach speeds of over 40 knots. Not only is it fast, it's adaptable. Its wide beam allows a 1,050 square meter flight deck and can accommodate smaller vessels below ready for launch, extending the ship's capabilities across the world's oceans.
Trimarans are stable platforms, and those are really important when you're doing things like operating helicopters, launching vehicles, and conducting high-speed maneuvers when you're doing surface warfare type events.
At sea level, the unique engineering is clear.
You get a really good perspective of just how wide the ship is and how that trimaran design provides for stability.
Commander Douglas Mayer is traveling between its outriggers, also known as armors.
We've got over 200 feet worth of armor tunnel here, where as the ship transits through the water at high speed, you get the very slender main body hull, and you have this armor that's cutting the water and maintaining the ship's stability at 40 plus knots. Any other ship in the Navy, you're not going to be underneath the main hull form of the ship like this. This is a one-of-a-kind design.
In its home port of San Diego lies the US Navy's fastest ever fleet. Engineered for coastal missions, both the Freedom and Independence littoral combat ships are changing the face of nautical design.
The littoral combat ships are at the cutting edge of naval technology that allow us to operate at high speeds in shallow waters with ability unmatched by any other naval ship of this size.
As the USS Montgomery powers out to patrol the Californian coast, Commander Mark Stefanik is at the helm of one of the world's most advanced vessels.
Nope, he is definitely cutting the channel. Let's give him 5 short.
But in these busy waters, unforeseen hazards are around every corner.
Got jet ski off our port side, 350 heading forward aft.
All right, I think we have a good shot at taking them down our starboard side. All right, steady she goes.
Steady she goes, 178.
So there's a number of sailboats that we had to maneuver for, as well as some other small craft. So that did add to the complexity of the ship trying to get underway.
"80 years on, the littoral combat ships are tackling the world's challenging coastal environments.
Captain's on the bridge.
Carry on.
And crews aboard the Independence variant have the next generation of Watt's engineering genius at their disposal, the Sea Giraffe radar.
Given that this ship operates in the littoral environment, we need a radar that kind of packs a big radar punch, but in a small package. And that's what we get with the Sea Giraffe radar.
In congested, potentially hostile waters, this state-of-the-art system is the key to keeping the multi-million-dollar USS Independence safe.
Once we get here, we've got our critical points in for contacting harbor control.
Okay. There could be potentially several different small craft coming in up to 40 or 50 knots at the ship. You need to have that capability. Where there's a lot of ambiguity between the good guys, the bad guys, and the in-betweens.
Sea Giraffe can detect 200 air and up to 400 seaborne targets simultaneously. Simplifying a complex picture, its advanced technology analyzes critical characteristics such as altitude and speed, deciphering a threat level within seconds.
Its ability to provide a very clear picture to the operator is what makes it special. We can separate the wheat from the chaff on a radar picture much better than a traditional radar would.
And despite its impressive capabilities, this advanced radar system is significantly smaller and lighter than a typical destroyer's.
It all is in keeping with our desire to maintain speed and agility, and it's a perfect fit for LCS.